video is our day 2 on lesson 5.2. So today we're going to get into graphing polynomial functions and then just a couple other ideas as well. When you graph a polynomial function, we are going to approach this just by doing a table of values. What you saw in the last intro video was how to figure out what's happening on the ends of your graph, that end behavior. So is your graph going up or down on the right? Is it going up or down on the left? What we don't know is what is your graph going to do in the center, kind of the heart of the graph. And so that's where we'll actually plot points from a table of values. The x values that we're always going to plug in, just to give us that center of the graph, oops, that's not going to be negative, is just going to be a -2 to a +2. So we'll plug in those same values for x every single time we graph in this chapter. Before we get to the graphing, however, let's go ahead and predict what the end behaviors should look like. And then as we plot our points, we'll know if we did the math right, if we're on track, if we know what it should look like. So it gives us a nice check when we do our graphs. So just to review the end behaviors again, f of x approaches, so this is saying what is the graph doing? As x approaches a positive infinity, that is the right side of the graph. So to talk about the right side, I know I have to look at the leading coefficient. That's a negative, which means I know the graph is going to go down on the right side, which means it's approaching a negative infinity right there. On f of x, so the next one, f of x approaches, so what is the graph approaching? As x approaches negative infinity, that is the left side of your graph. So for that, we look at our degree. It's odd, which means we're going to do the opposite as what the right side did. So if the right side is going down, I know the left side will go up, which means this will be a positive infinity. So now we're just going to do a table of values, and we'll just make sure that it is matching what we said the end behavior should do. So when you plug these in, we have f of x equals a negative x to the 5th plus 2. We're going to plug in -2 to 2 on this, and this is one to be really careful about. Whoa, anytime you have that negative in front of your x. So what that is going to look like when you plug in a -2, you're going to have a negative, and then your -2 to the 5th power plus, to the 5th power, just kidding, to the 2nd power, plus 2. When you do this, you have to do your exponent first. So a -2 squared is a +4, and then we bring that negative down. So we really end up with a -4 plus 2, which is a -2. And we're going to do the same thing, a -1 squared plus, oh no, it is to the 5th. Helps to pay attention to what you're doing, doesn't it? I was right the first time. So let's use this color. This is to the 5th power. -2 to the 5th power is a -32. Then a -32 becomes positive. And a +32 plus 2 is 34. So this should be 34. Hopefully you guys caught that before I did. All right. -1 to the 5th power is a -1. Bring down your negative, plus 2. So you have a -1, which becomes +1, plus 2, which is 3. 0 is always such a great one to plug in. You have a -0 to the 5th plus 2. Well, 0 to any power is 0, so plus 2 is just 2. And then you have a -1 to the 5th plus 2. 1 to the 5th is 1. Bring down your negative. Add 2, and we're getting a 1 out of that. And then lastly, we have a -2 to the 5th plus 2. 2 to the 5th is 32. Bring down your -2. Plus 2 is a -30. So now we can go and plot these points on our graph. Let me zoom out a little bit. Now, it's going to be very common where you're going to have points that go off of your graph. That's okay. We'll at least know that those points are up there somewhere. So first we have a -2. So -2, +34 is way off the graph. So we can't plot that one, but we know that it's up there. Next is a -1, 3. And then 0, 2, 1, 1. And then this 2, -30 is way off the graph. But because we know that those points are there, I know that this is going to connect and head up toward that +34. This is going to connect and head down toward that -30. And as you can see, our graph is going down on the right like we said it was going to. It's going up on the left like we said it was going to. If those didn't match, then I would go back and try to figure out what was wrong with the table of values. But there's our graph. You just plug into your function, get your points, plot them, and we're good. So, synthetic substitution. This is something you guys have not seen before. Synthetic substitution is just another way to find what you would get if you were to plug this -4 in for all of your x's. If you do just plug a -4 in for x, that's called direct substitution. That's what you guys have been doing forever. Synthetic substitution is just another method. Sometimes it's much quicker than direct, sometimes it's longer. It kind of depends. But either way, it's nice to have more than one way to evaluate a function at a specific value. So, the way that synthetic substitution works is we need to grab all of the coefficients from your polynomial starting with the highest, the leading coefficient. So your x to the 4th, the coefficient with that is a 1. Then we move on to your x to the 3rd, and we have to grab that coefficient of 3. Now we go on to x squared, we can see there's a -2. X to the 1st has an 8. And then that's all that our polynomial shows, but you also have an x to the 0 power. You do need to represent every single exponent from the degree on down to 0. So what would have been in front of this x to the 0 power to make it go away? A 0. So if you're missing any of your exponents with x, you have to fill it in with a 0. Then we do our little table. Whatever value you're trying to evaluate, you put out here. So we want to know if you plug a -4 into our polynomial, what do you get? Only we're going to do this with synthetic substitution. So the way that synthetic works is you start by bringing down your first coefficient. And now it's just a pattern of multiplying and adding, multiplying and adding. So if you can add and multiply, this will be no big deal. It's just a matter of remembering how it works. So you're going to start by taking the 1 and multiplying it by that -4. We always go back and multiply by that -4. The answer is going to go diagonally up this way, so you get a -4. And then you're going to add down. So 3 plus a -4 is -1. Now you're going to go back and multiply -1 times the -4. We get a +4 this time. And then you're going to add down. So -2 plus 4 is 2. Now we'll multiply 2 times the -4. And again, that's going to go up here. We'll get -8. We add down to get 0. Then we multiply 0 times -4 and we get 0. When you add down, you get 0. So hopefully we did that right. Whatever this last number is right here, that is your answer. If you were to plug a -4 in for all these x's, do your exponents first, then you're multiplying, then you're adding or subtracting, following your order of operations. In the end, you would get a 0 back as your answer. And that's synthetic substitution. I think it's a nice alternative. Again, a lot of times faster. Sometimes, because you're just adding and multiplying, you tend not to make as many mistakes. If you were doing this problem up here, you have exponents, you have multiplication, you have addition and subtraction, just a lot of opportunities for those little math mistakes that we make. So make sure that you do learn the synthetic, you are tested on this particular method, and then the direct, which you already know, you're tested on that as well.